Hello everyone. So today we have a very interesting question with us. This is more of an IQ based question. So the question says that we have a group of 70 people, right? And the condition in this group is that let's say we choose any two people. We choose any two from the 70. Let's say we choose some X and Y, any two people. So what will happen is there will exist some language for this person X that only X knows but Y does not know, and there will be some language for Y that only Y knows but X does not know, right? And in that way we are asked that what are the minimum number of languages, that this entire group speaks, like the minimum number of different languages that this entire group speaks. Now when I first saw this question, I'll just tell what I thought very initially, like within maybe 10 15 seconds. What was the initial thought? So the initial thought was, so let's say I have 70 people, like 1 2 3, and like that I have 70 people. This is the 70th person. So let's say one has a language that only one knows, okay, that only one knows, okay, some language A. Now two has a language that only two knows, three has a language that only three knows. So see, if three has a language that only three knows, then none of the people in this group, the other 69 people, they definitely don't know that language, right? So the entire condition is satisfied, right? So 70 different languages if we choose, then definitely this condition is satisfied, and that becomes a, like, very basic question. Someone from class 6 7 could even answer that. But then why is it a bit difficult? Like, not difficult, but why is it a bit tricky? So it's tricky because the idea that one should think about, the correct idea is that, or the intuition is that, uh, what we are trying at the very beginning is we are trying to select one language and distribute, right? But why not do this, that let's assign two, or let's assign two or more than two, let's assign multiple languages, right? Let's assign multiple languages to one particular person and try to get some unique combination. Like, what I'm trying to say is that, let's say we have six balls, okay, or let's say I have four balls. So I can choose these two, I can choose this two, or I can choose this two. Why not make it look like a PNC question, and try to see what are the maximum ways, what are the distinct ways of choosing. So I'll just show you an example that, like, for six people, I'll just take a small group and I'll show you that, let's say for six people, if I want to do this. So, like, let's say I have four languages, L1, L2, L3 and L4, right? I have these four languages, and I have six people. So I have P1, I have P2, I have P3, I have P4, I have P5, and I have P6. Now let's say P1 knows L1 and L2. Now let's say P2 knows L1 and L3. This is okay till now, right? Because for P2 there's a language L3 that P1 doesn't know, and for P1 there's a language L2 that P2 doesn't know, right? Now let's say P3 knows L1 and L4. So again, till now this is all fine because L4 none of these two guys know, okay? And for P3 also, for, like, till P3 this condition is satisfied. Now let's say, how do we choose two languages for P4? Now let's say I choose these two. If I choose these two, so this language P1 doesn't know, this language P2 and P3 doesn't know, right? So till now it is satisfied that P4 also has a single language at least that any of these three guys don't know, right? Is it satisfied for the other cases? So, like, for P2, if I say, so P2 has this language and it has this language, so this language P4 doesn't know, and this language both P1 and P3 doesn't know. So till now it's fine, right? Okay. Now for P5, let's think for P5. So P5 can choose this and he can choose this. Now if he chooses this, it is all okay for P1, P2 and P4, because P1, P2 and P4 don't know this language, that is L4. And but who knows L4? Who knows L4? L4 is something that only P3 knows, right? So I have chosen a safer position, L2. that L2. Now see, like this language is not known to, is only known to P3. So therefore I must choose a language that P3 doesn't know. So P3 doesn't know L2, so I've chosen L2, right? Okay. So now for P6 when I choose, so let's say I again choose this. Now for these three it is okay, but P3 knows this language and P4 knows this language. So I must select some language that both P2 and P4 doesn't know. And which language is that? Which language is that both P2 and P4 doesn't know? So I can again choose this. But then this is a mistake for P6 and P5. So I can't choose this. I can't choose this. Then what should I choose? Maybe choosing this is a mistake. So what can I do then? Let's think. Let's think. Let's say choose this. Let's say I choose this. So P5 knows, P4 knows, P1 knows this. So I need to have something that all of these guys don't know. So if I choose this, then that will be common with P4. So I need to have some combination that doesn't exist yet. Okay, which is that? Which is that? I need to think. Uh, which combination doesn't exist till now? Yeah, this is the combination that doesn't exist till now. Correct. So I can choose this too. If you see, so this is the language that only P5 knows and P3 knows, and this is a language that both P3 and P5 doesn't know. So what could you see at the end of the day? That we were choosing two languages from a group of four languages, right? And as 4C2 is equal to 6, right? What did we do? That's only what we did. We chose two languages from a group of four languages, and there were six distinct ways of choosing those two languages, right? Like this two tick ones, this two tick ones. So there were six different ways, and therefore we could assign it to six. Like see, if you choose a person P7, you will never be able to do that. You will never be able to do. You can just see that there exists no different combination. So six was the maximum that we could go to. We can't assign the same way and do this, right? Like with four languages I'll never be able to do this for seven people. It's impossible. Why is it so? Because it's always about choosing. What are we doing at the end of the day? We're just choosing x languages from n languages. It is nothing but n choose x. We are choosing x languages from n languages, and we need to maximize this. Whatever is the maximum value of this is the number of people that can be satisfied. Okay, so now do you know when does ncx attain its maximum value? When does n choose x attain maximum value? It is at x equal to n by 2. I hope you know this. Like for 6, if we see, so 6c0 is 1, 6c1 is 6. So like that 6c2 will be 6 into 5 upon 2 is 15, and 6c3 is 6 into 5 into 4 upon 6, so it is 20, right? So that way 63 is the largest one. So always at x equal to n by 2, ncx attains its maximum value. That's something we already know. So we need to have 70 different ways of choosing, right? And that needs to happen that ncx is equal to 70. And what will be like, and we need to maximize n. We need to minimize n, right? So we need to minimize n. We just need to think for an x such that ncx is maximized. हमें वो सबसे छोटा n चाहिए such that ncx maximize हो जाए, है ना, 70 लैंग्वेज आ भी जाए एंड n भी सबसे छोटा हो. That's our requirement overall. So if we are trying to do that, uh, let's just try, because x will be n by 2. That is something we already know. तो हमें पता है, जैसे हम अगर let's say we start choosing x. Let's say if we have x equal to 1, so we will have to choose 1. It's of no use. Let's say we have 4c2, so 4c2 is also small. 6c3 is also small, it is 20. But if we look at 8c4, do we know what the value of 8c4 is? It is 8 into 7 into 6 into 5 upon 24. So it is 7 into 2 into 5, which is 70. So therefore 8 choose 4 is 70. So therefore your n is nothing but 8. Right? So basically the point is that if the group speaks 8 different languages, right, and you distribute 4 languages to each person, we will have 70 different ways of choosing, and that will satisfy this thing that there will be no exact same combination, there will be no exact same way of choosing, no exact same combination, right? There will exist at least one difference, one point of difference will always exist. That's why they're all unique ways of choosing, and therefore the answer is 8, right? I hope you have understood the question. Thank you.